biotransformation of the drugs. As usual, first, let us clear the term biotransformation. What does this term mean? Bio means life, transformation, to transform, to change in the life. What? Drugs. So how will we change the drugs in the living organism? That is actually the biotransformation. Well, pharmacologically, we define the term biotransformation as when the drug that you take interacts with the enzyme and then that drug is changed. This is called biotransformation. Now, why are we supposed to change the drug? The reason is that when the drug stays for a longer period of time in the body, it will cause toxic effect. So we don't need toxic effect. We are using it as for the sake of therapy to treat the living body or to treat the disease. So for that reason, we are supposed to change it. Some reasons are there. In the pharmacokinetic steps, we remember absorption, distribution, metabolism, and elimination. Metabolism. After the metabolism, the elimination will occur. First, when you take the drug, it is supposed to be metabolized. When it is metabolized, then it will eliminate from the body. Why do we metabolize? Again, the question rises. The drug that you take is first of all in the lipid form. That is lipid soluble. You can say lipophilic. So the lipophilic drugs, when you take it through any route of administration, so when they enter the body, what will they do? They will be absorbed very, very easily. Absorption will be done, then distribution will be done. So again, we want now to eliminate it. Why? Because we don't want the drug to stay for a longer period of time in the body. So what will we do? We will just interact that drug with another enzymes, or the drug will interact itself with the enzymes. After the interaction, the drug will become from lipid soluble to the water soluble. When the drug becomes water soluble, then it is easy to clear from the body. Then the question rises where this biotransformation takes place. Very simple answer. There are the following general types. Number one, these are the sites. Number one is liver, where the biotransformation takes place. Lungs, skin, GIT, and kidneys somehow, etc. And liver, the very prominent site where 90% of the biotransformation takes place. The reason is that it contains the mitochondria, which is responsible to do the metabolism. And by the way, it is the highly energetic part of the body. That's why it contains the process of metabolism, that is biotransformation, will take place here the most. Next, how this biotransformation will occur in the body. It takes place by means of two phases. Phase number one, phase number two. Phase 1 biotransformation, phase 2 biotransformation. So now the very thing that you must keep in mind is that we are converting the lipophilic drug into water soluble, or you can say hydrophilic. So phase 1 will also convert the drug into hydrophilic, and phase 2 will also convert the drug into hydrophilic. So for that, the phase 1 contains three types of reactions. 1 and 2 means redox is actually reduction and oxidation. And number 3, that is the hydrolysis types of reactions. So we have oxidation, reduction, and hydrolysis. By means of these three reactions are responsible to convert the lipophilic drugs into hydrophilic. How? We have in the oxidation, in the reduction reactions, they take place in the cells of the liver, lung, skin, etc. by means of microsomal enzymes and non-microsomal enzymes. As I told you before, that the drug is supposed to interact with the enzymes. So we have somehow microsomal and non-microsomal enzymes which are responsible to do the metabolism of the drug. Means how they will metabolize? They will just convert from the lipid soluble to the water soluble. So the microsomal enzymes are actually composed of cytochrome P450 and NADPH cytochrome P450. These two are the components of the microsomal. And non-microsomal enzymes are the enzymes other than these two. Whatever the enzymes are present, they are called as non-microsomal, and they are present in the, you can say, in the cytosol, or in the mitochondria. These are available to do the metabolism of the drug. So by means of these oxidation reduction reactions, they will metabolize the drug by means of microsomal enzymes and non-microsomal enzymes. And you know about the oxidation process, where you are going to do, as we are supposed to do, the addition of oxygen, loss of electrons into some compounds. Like this, what will happen means whenever you do the oxidation reduction or the hydrolysis, you are actually removing, adding, and somehow like that. When you remove the electron, it is called what? Oxidation. When you add, it is called reduction. And when you do the hydrolysis, when you add hydroxyl group or hydrogen group or just water to the compound, you are just actually adding the positive or negative charges on that compound. When a compound becomes charged, it is actually becoming a polar. So polar is actually the water soluble now, means that will interact with the water and then easily will go out from the body, will not be reabsorbed from the liver, from the kidneys, and from other sites. So like this, by means of oxidation reduction and hydrolysis, you are actually converting the structure of that lipid soluble into water soluble by means of adding charge. When you give that compound or that molecule, that substance or that drug a charge, the drug will become charged, and then it is easy to remove the charged particle from the body is compared to the chargeless particles or the substances which are present in the body. So the charged particle will move very easily. For that sake, the redox and hydrolysis reactions will just impart or will just give the charge to that compound, and that will become polar. And you know, polar are easily to be dissolved in the water, and like that they will become easily, you can say they will easily be eliminated from the body. And what is the difference between redox and hydrolysis? Redox reactions are actually different in case of microsomal and non-microsomal. These reductions, redox means oxidation reduction reactions, they will do the metabolism by means of microsomal and non-microsomal, whereas hydrolysis will do the metabolism just by means of non-microsomal. That's the main difference. And their main cause and main function is to impart the charge on that specific drug in order to make it water soluble. Well done. Phase 2 reactions. What are phase 2 reactions? In the phase 2 reactions, we just do conjugation. What is conjugation? The name indicates to conjoin, to join something. Here what will happen? Sometimes when the drug passes from the phase 1, this drug is not that much soluble, water soluble. So what happens then? Then it enters the phase 2. In the phase 2, there is glucuronic acid present, amino acid, acetic acid, and some other acids, which will then combine with those products of the phase 2 and will help in making that product more polar. So I told you again, when the drug will become polar, then it is easy to eliminate that from the body. Then that drug will be eliminated very easily. So like this, conjugation is actually combination of glucuronic acid with the phase 2 product, or the amino acid with that product of the phase 1, or the acetic acid with that product of the phase 1, in order to make it more polar. Sometimes what happens, when you take the drug, that drug might enter the phase 1, and then after the hydrolysis, after the redox reactions, it will enter into the phase 2. Phase 2. But sometimes when you take the drug, that directly goes to the phase 2, where it will just go for the glucuronidation, means the addition of glucuronic acid to that drug, and it will be eliminated from the body. So phase 1 can be skipped. That is the very important point. Sometimes when you take the drug, they might skip the phase 1 because they are polar enough, and they will enter directly to the phase 2, where they will just have the interaction with the glucuronic acid, means either the glucuronic acid or amino acid or any other acid that will combine with that drug, which is a little bit polar, and that will become more polar, so then it is easy to be moved or eliminated from the body. So phase 1 is actually redox hydrolysis, and phase 2 is conjugation. In the redox and hydrolysis, the main mechanism of the biotransformation is done by microsomal and non-microsomal enzymes, whereas in the conjugation there is the addition of the acids like glucuronic acid, amino acid, acetic acid, and very important point, that sometimes when you take the drug, it might skip the phase 1 and will enter directly into the phase 2. But the main strategy is that the drug is supposed to first enter to the phase 1, where it is supposed to go through the hydrolysis and or redox reactions, then it will enter the phase 2 reactions. After that, when it has become more, means enough polar, then it will be eliminated from the body. That's it all about the biotransformation. Hope so. You got it. Thank you.